All right, let's see if we can actually prove a theorem. So, with a theorem, we'll have some given part and then the challenge of what, in fact, we're asked to prove. In this case, we're given a lot of information. We're told that angle ACD, let's see where that is, ACD, and angle ACB, these two angles are right angles. So I'm going to mark them in. As we gain information, I'm going to mark this figure. So I'm going to denote these angles as right. C is the midpoint of the segment BD. So in fact, C is the midpoint. Okay, we have to remember that. We know also that AD is congruent to AB. That means that this side is congruent to that side. And we also are told that AC bisects angle A. So this is an angle bisector. Now, what we want to do is show that triangle ACD, this triangle here, is congruent to triangle ACB. How do I do that? I have to show that corresponding sides are congruent and corresponding angles are congruent pairs. So let's take a look and see if we can find these pairs. Well, this side and this side of those triangles are congruent. So this is a pair of sides that are congruent. Great. Can we find another pair of sides that are congruent? Yeah, the easiest one is going to be AC, because AC is the exact same side of this triangle as this triangle. So in fact, since AC equals itself, I know that this side of this triangle corresponds to this side of this triangle and, in fact, is congruent to itself. Great. So now I have two sides that are congruent. What about this side compared to this side? Well, remember that C is the midpoint. And so by the definition of what it means to be the midpoint of a line segment, we know that point actually cuts up the segment into two pieces of equal length. So this length, CD, equals this length, BC. So in fact, I see now that I can mark this as being equal in length to this, and therefore they're congruent. Look what I've just showed. I found pairs of corresponding sides of the two triangles that are congruent. I'm halfway home. Now I've got to look at angles. Well, let's see if we can figure out the angles. Well, I know that this angle is a right angle and this angle is a right angle. That means both have measures of 90 degrees. So each of these pairs of angles can be thought of being a, in fact, congruent set of angles. We're also given one extra piece of information, which is that AC bisects angle A. And by the definition of what an angle bisector is, it means that it cuts up angle A into two congruent angles. So these two angles can be thought of as corresponding parts, and they're congruent. What about these two? Well, I don't know anything about these. However, I do know that the sum of the angles of a triangle have to be 180 degrees. I know that this is a blue angle and this is a purple right angle, and so therefore if I add these two up, I know that this angle will be 180 degrees minus that sum. Now let's take a look at this triangle. Well, I see the exact same thing. I see the blue angle and the purple right angle, so when I add them up, I'm going to get the same sum as I got before. When I take 180 degrees minus that sum, I'm going to get the measure of that angle, which is exactly equal to the number we have here. So the measure of these angles actually same, which means that these angles are in fact congruent. Well, I have corresponding pairs of corresponding parts of each of these triangles being congruent, which means by definition, triangle ACD is congruent to triangle ACB. And we've just proved this as a theorem.